In this lecture, we will discuss about the applications of the elasticity. We have gone through the solids, we have gone through the stress-strain, the Hooke's law, the stress-strain relationship. Now, we will discuss the knowledge of elasticity is needed. What are the applications of elasticity? First one is when we design the machinery parts are never subjected to the stresses beyond elastic limit, because in that case, machinery parts will get permanently deformed. The cranes or the machineries designed to lift the heavy weights by the help of metallic ropes with attached to this shaft and a motor. Now, when the ropes are designed, those ropes are designed to work under the braking stresses. That means the stress developed in the wires must not exceed the braking stress. That means the working stress should always be lower than the braking stress, or the safety factor is kept high. As we have already discussed about the safety factor is the ratio of braking stress to working stress. If the working stress is low, that means the value of the safety factor is high. So when we use the cranes, we should work with the high safety factor. So there is no risk of breaking the rope that will lead to the accidents and even the death of the employees. Now, important one is design of bridges. How do we design the bridge? One thing is to be kept in mind while designing the bridge, that is the depression in the bridge must not be high. What is the depression in the bridge? That is given by the delta. We know that let this be the bridge, this is the middle line of the bridge, like the center of the gravity. When weight is kept on the bridge, or when the weight is moving on the bridge, then there is a slight depression in the bridge. So this depression is given by WL cube divided by 4YBD cube, where W is the weight on the bridge, L is the length of the bridge, 4 is the constant, Y is the Young's modulus, B is the breadth of the bridge, and D is the depth of the bridge. Now, in order that depression should be low, the length should not be long enough. That means if the bridge is long enough, the depression is high. How we are going to tackle this? When we have got long bridges. When we have got long bridges, we will give them support at regular intervals. When we give them support at regular intervals by the help of the pillars, the length is decreased. The length is decreased, so the depression is decreased. Next thing, we cannot increase the breadth too much. We can increase the depth. So, when the depth of the bridge is large, that means this depression is low, because here we have got inverse relationship, and that too inverse cubic relationship. That means D should be high. When the depth is more, then the depression is less. Now, we are having a trade-off between the B and D, because by increasing D, we increase the weight of the bridge, and the bridge can collapse under its own weight. And that bending is called as the buckling. The buckling is reduced by designing a bridge, and the design is in I shape. It is called as a grider design. So, by the help of grider design, we get a trade-off between the breadth and the depth. So, the knowledge of elasticity is important. And another thing, when we are having poles, we can have solid poles or we can have hollow poles too. The hollow poles are better for installation than the solid poles, because the torque required to bend the hollow pole is much more than the torque required to bend the solid pole. That is why in the electrical installation we always use the hollow poles of steel, not the solid poles. The solid poles of cement wire used and the solid poles of wood wire used, but we don't use them nowadays, because we know that from the knowledge of elasticity and the application of elasticity, the torque needed to bend a solid pole is much less than the torque needed to bend the hollow pole.